The first important feature of taste is the degree to which individuals are willing to substitute goods for one another. And as we've seen in the previous three graphs, this degree of substitutability is a feature of the shape of the indifference curves we draw. The second important feature of tastes, on the other hand, has little to do with the shapes of indifference curves. Rather, it has to do with the way that indifference curves within an indifference map relate to one another. We'll begin to explore this here. Let's return to the example of pants and shirts, and suppose that I currently own bundle A, which contains 3 shirts and 3 pants. There's an indifference curve that passes through bundle A, and suppose that its slope is equal to -1 at bundle A. This gives us a marginal rate of substitution for me equal to -1 at my current consumption bundle. This marginal rate of substitution seems plausible. If I have equal numbers of pants and shirts, I might be willing to trade them 1 for 1. Next, suppose that you double my current consumption bundle to 6 shirts and 6 pants, giving us bundle B in our graph. We again have an indifference curve that passes through bundle B, and the question is, what slope might we expect for that indifference curve at bundle B, or what marginal rate of substitution might we expect at bundle B? I argue that it's reasonable to assume that the marginal rate of substitution at bundle B is also equal to -1. The reason for this is that I once again have an equal number of pants and shirts, and since every time I wear a shirt I also tend to wear pants, it seems that if I'm willing to trade them 1 for 1 when I have 3 of each, I'm probably willing to trade them 1 for 1 when I have 6 of each. So it seems reasonable to me that our marginal rate of substitution will remain the same as we double my consumption bundle for this example. Now suppose we had started at bundle A prime instead, a bundle that contains more shirts than it does pants. In that case, we would have been willing to give up more shirts for every pair of pants since we have relatively few pants. Thus the marginal rate of substitution at bundle A prime is larger in absolute value than the marginal rate of substitution at bundle A, say -2 instead of -1. Now suppose that we double the consumption bundle A prime. Instead of 4 shirts and 2 pants, we now have 8 shirts and 4 pants, which gives us bundle B prime. For the same reason that it was reasonable, I think, to assume that the marginal rate of substitution from A to B does not change, I think it's reasonable that the marginal rate of substitution from A prime to B prime doesn't change. We again doubled the consumption bundle, but left the ratio of shirts to pants in our consumption bundle the same. So if we're willing to trade 2 shirts for a pair of pants when we have twice as many at bundle A prime, I think it's reasonable to assume that we're still willing to trade them 2 for 1 at bundle B prime, where we again have twice as many shirts as pants. Next, suppose that same logic holds for any initial bundle A. That is to say, if we know the marginal rate of substitution at a bundle A, we also know the marginal rate of substitution at any multiple of the bundle A where the ratio of the 2 inputs remains the same. We would then get an indifference map that looks something like what we've drawn here in panel B. All the bundles at which the marginal rate of substitution is equal to -1 would then lie along a single ray from the origin, because it is along that ray that multiples of a bundle A that might lie on the magenta indifference curve would lie. The same would hold for any other set of bundles for which the marginal rate of substitution is the same. For instance, the set of bundles for which the marginal rate of substitution is equal to -1/2 would lie along a ray from the origin that is shallower than where the marginal rate of substitution is equal to -1, and the set of bundles for which the marginal rate of substitution is equal to -2 would lie along a ray from the origin that is steeper than where the marginal rate of substitution is equal to -1. And the ray along which the marginal rate of substitution is equal to -2 would contain bundles A prime and B prime from panel A, while the ray along which the marginal rate of substitution is equal to -1 would contain bundles A and B from panel A. The particular feature of taste that we've developed here is not a feature that will apply to all tastes, but when it does apply, we say that those tastes satisfy the homotheticity property, or we'll say that those tastes are homothetic. Homothetic tastes have the special property that the marginal rate of substitution depends only on the ratio of goods in a bundle, not on the absolute quantities of each of the goods in the bundle. So, for instance, if we have twice as many shirts as pants, we know the marginal rate of substitution will be the same regardless of how many shirts we have. What matters is that we have twice as many as pants, and for all those bundles, the marginal rate of substitution is the same. Notice that this homotheticity property has very little to do with the shapes of the individual indifference curves. Rather, it's a property of how indifference curves relate to one another. If someone has tastes that can be represented with the indifference curves for perfect substitutes, for instance, that person has homothetic tastes, because along any ray from the origin, the marginal rate of substitution is unchanged. In this case, it's the same everywhere. Similarly, if someone views two goods as perfect complements, that person has tastes that are also homothetic. And there are lots of cases in between, where we have varying degrees of substitutability built into indifference curves, but the tastes overall still satisfy homotheticity. This homotheticity property will come in handy once we talk about income effects in Chapter 7, where we discuss changes in behavior as income changes, and as individuals therefore move between indifference curves. As they jump from one indifference curve to another, it is the relationship between indifference curves that matters, and if we know the tastes are homothetic, we'll be able to make some fairly precise statements.